Alright, number 8, we're going to solve by using the square root method again. We have in parentheses 5y plus 18, and this is all squared, and that equals 48. Okay, so the square root expression is already by itself. We're going to take the square root of both sides. I'm going to do the square root of 5y plus 18. And then when I do the square root of a number, you have to remember that plus or minus. Square root here will just cancel out the square, so no need for plus or minus. We have 5y plus 18 equals, we're going to reduce this radical, positive or negative. So out to the side, I'm going to do square root of 48. This can be broken down into, let's just do it as 3 times 16. And I just picked that, and it doesn't matter what you use, you will eventually get to the same end result. But I tried to pick a number that was a perfect square, so that when I do 16, I can write that as 4 times 4. Okay, so I get to bring a 4 out. And then the 3 will stay. Now let me show you, if you do this another method, you will still end up having a 4 on the outside. So let me just show you. A lot of people we'll just break it down and divide it by 2 because it's even. So we'll just say 2 and 24, and then 2 is prime, so 24 is still even. We can do 2 and 12. Okay, so we got a pair of 2's. A 2 will come out. 12 is even. We can break it down to 2, and I'm running out of room and off my space. 2 and 6, and then 2 is prime. 6 is still even, so 2 and 3. Alright, so look, we got 2 2's that we bring out. So if you bring out a 2 and another 2, you multiply those 2 together and you get 4. So if you can find a perfect square, you don't always have to go down to primes, the smallest number. It's a little bit less work as you understand the process, and you can stop a little bit short. But this is totally fine as well. It may be easier just to get to that point, because 3 and 16 aren't like traditional numbers that you would think of with 48. But this is going to be 4 square roots of 3. Alright, and then from here, we're going to set up our 2 parts to get our answers. We have 5y plus 18. We're going to set it equal to the positive of this. So it's going to be 4 square roots of 3. And then we're going to do the other side, 5y plus 18 equals the negative of it, negative 4 square roots of 3. Alright, we're going to subtract 18. Both sides are going to be exactly the same. Subtract 18 from both sides. That will go to 0, bring down 5y. That's going to equal a negative 18 plus, because that's positive, 4 square root of 3. You cannot combine these two. This 3 attached to this is acting kind of like the variable x, and 18 does not have a square root of 3 part at the back, so you cannot combine those two. You got to leave it separate. Same thing over here. It's going to go to 0. 5y equals negative 18, and it's going to be minus 4 square roots of 3. Alright, and then our last step, we got to get rid of the 5 on the y. So we're going to divide by 5 on both sides. Divide by 5. 5 divided by 5 is 1, so we end up with y equals, and then I'm going to write negative 18 plus 4 square root of 3 divided by 5, and then the other one is 1, y equals negative 18 minus 4 square root of 3 over 5. So these will be our 2 solutions here. I'm going to do a division bar first, and then negative 18 plus 4. We need our keypad, square root of 3, arrow down, and do 5. And then over here in the division bar, -18 minus 4, square root 3, and arrow down, and do 5. So double check, looks good. Alright, this one says we're going to solve by completing the square, so I might need to give you some rules for completing the square. This is not one that I was very fond of as I was younger, but as I got older, once I learned how to do it, and a simple way to do it, it made things a lot better. So, completing the square is actually the process that gave us quadratic formula when you do it with the letters A, B, and C. Okay, so to complete the square, your leading term needs to be 1. But before we do that, because things change up considerably, you can't just divide that out. We're going to first move this constant term over. We're going to move the 48. I'm going to add 48, so I'm going to have 4x squared minus 4x, and then I'm going to do plus blank, because I'm going to add something there, equals 48. So what I did is I added 48 and moved it over. Now, here's the problem. This needs to be a 1. So what I'm going to do is I'm going to factor out a 4. So you got to pretty much like divide everything by 4. Even if it's not evenly divisible by 4, you would have to divide that by 4 to get rid of that coefficient on front. So I'm going to have 4 on the outside, and this is going to be x squared minus x plus blank space, because I'm going to add something there, and then equals 48. Okay, so now the completing the square part. You take the term that's in the middle. The coefficient in front of that is 1. Whatever number it is, you take that. You divide that number by 2, and then you square the result. So 1 over 2 is a fraction. I'm going to leave it like that, and then when I square it, I'm going to add that to both sides. So I'm going to leave it in this form, 1 over 2 squared. 1, because I'm going to do something with that later. 1 over 2 squared. This is the perfect square term. Now, whatever you add to one side, you have to add to the other side. Now, here's the tricky part. This 4 eventually will distribute and alter this number. So I have written down 1/2 squared, but what I'm actually adding is 4 times this 1/2 squared. So let's figure out what this is, because that's what I need to add to this side so that they can be even. So if I do 1/2 squared, when you square a fraction, you square the top and the bottom. So 1 squared is 1, and 2 squared is 4. All right, so 1/4 is what that is. When you multiply that by 4, what happens is times 4, division by 4, they divide each other out, and you just end up with 1. So what you actually added to both sides was 1. Okay, and so that's what you need to add over here. Now, the reason why I left it as squared, because there's a shortcut to completing the square. Once you figure out that term, you leave it like that. The shortcut is I'm going to bring the 4 down. I'm going to do parentheses. You take the 2 terms with squares on them, the x and the 1/2. You're going to put those together in parentheses. The sign should be the same as this one because it was negative. I got to be careful with that. That should be negative, because when you square negative, it turns positive. Half of -1. So this should be a negative here. So that should be a negative there. I got to be careful. Take the 2 terms that have a square on them, put them in parentheses together. Okay, keep the sign of the middle term, and then the square goes on the outside. That is the shortcut to factoring it, because it's hard to factor when you got fractions. Now, you might be wondering, where did that negative x go? We just get rid of it? No. When you FOIL, or if you write this out twice and distribute, that x will still be there, and you will see it, but for now, just take my word for it. 49, and I can show you later. Just ask me or message me, and I'll show you that process. So this is what we get, and then we're going to go through the solving process. I'm going to divide by 4 on both sides. So we get rid of that. Divide by 4. That's not divisible evenly, so I'm going to leave it like that. 4 divided by 4 is 1. And then I'm going to bring down my x minus 1/2 squared, and that's equal to 49 divided by 4. Alright, now the square root property. Got to get rid of the square. Square root. When I do the square root of a number, positive or negative, has to be remembered. Square root will cancel each other out. So that's going to leave me with x minus 1/2. And then over here, it's the same as saying the square root of 49 over the square root of 4. You can give them both their own and just do them individually. The square root of 49 is 7, and the square root of 4 is 2. Okay, so we get x minus 1/2 equals positive or negative 7/2. And then one more step, we're going to set these and solve them. So we have x minus 1/2 equals positive 7 over 2. And we have x minus 1/2 equals negative 7 over 2. Alright, when I add 1/2, the like terms on the bottom are the same, so I end up with x equals 1/2 plus 7/2, and you can add and get 8/2, which reduce to 4. And then over here, you'll add, so we have x equals 1/2, and then since that's negative, minus 7/2. When you subtract those, you get 1 minus 7 will give you 6/2, negative 6/2, that is, negative 6/2. 6 divided by 2 is 3, or negative 6 divided by 2 is negative 3. So you get negative 3. So you get two answers, negative 3 and 4. Okay, that is a process. And that's why I didn't like it, but I can do it now, so it's not so bad. We definitely need to see that again.